Let's start. Good morning or good evening to all, and welcome to the Data-Driven Community virtual meeting. Let's start with a few words about the Data-Driven Community. For more information, simply check the community website. I will add the link in the chat in a few minutes, so don't worry about this. If you go to the main page and you scroll down a bit, then you can see the community upcoming events. On the left side of the page, you can notice the information about the Future Data Driven Summit. This is an annual joint conference we are leading with multiple data platform user groups partners. This year, conference is over, so let's focus on the right side of the activities. The second branch of activity we run are the weekly meetings of the Cloud Data-Driven User Group, like today. And here you can follow our next weekly meetings. You are more than welcome to contact any of the community board members. We have, of course, Jen Joseph, who is the founder and co-administrator of the community. Daphne Gugori is a moderator and event organizer. And myself, my name is Ronen Arieli. I'm from Israel, working as a senior consultant in the field of data platforms and architecture of enterprise-level systems. I am administrator of the data-driven community, and I will be hosting the session today. Together, we are here to help and serve the data platform community. Note that we disabled the chat for this meeting. During the meeting today, please feel free to use the Q&A. Basically, it's exactly the same. You can use it for questions and discussions as well. You are also welcome to use the reaction. This is something I like a lot. It does not interfere with the course of the meeting. If you hear something that you love, like, or you just want to clap hands virtually, of course, feel free to do so. I'm honored to introduce our guest speaker for today, Ed Pollack. Ed is a data architect, Microsoft Data Platform MVP, but the most important, Ed is supporting our community for many years. He is like our finance supporter, and he followed us a few of the Future Data-Driven Summits in the past as well. Okay, Ed, please share your screen, and you can add a few words about yourself.
All right, sounds great. Thank you very much for having me. So here's my screen. This is a lot today. I'm going to dive in pretty quickly, move fast, but feel free to ask questions. If you don't have a chance to ask a question today, we can continue the conversation later. So this is all about today, data fundamentals. Despite everything going on in the world, data moving faster than ever, development, AI, machine learning, there's so much happening out there right now that's exciting. I keep returning to this. This keeps coming back. No matter how fast we want to move, the fundamentals of how we store, retrieve, and manage data don't go away. And if we forget about them, bad things happen, which we'll talk about here. But real quick first, here's me. I'm Ed Pollack. I've already got an intro from Ronan, so I'm not going to repeat everything he said. I do a lot in the world of data. I publish books, I write articles, I organize events. If you happen to ever be anywhere in the Northeast United States, feel free to stop by and check out an event I'm running. Otherwise, I do travel to a lot of other events as well. So hopefully I'll see you around in person or maybe virtual. We're going to jump right on into what am I even talking about? What is this thing I made up, data fundamentals, and why are they forgotten and all that? And that's straightforward, I think. We know when these things are forgotten because our lives become difficult. Then we're going to talk about how they relate, especially because this is important. All the fundamental principles of data that we talk about relate to each other and to cost, which is important, but they relate to each other. When one suffers, the rest also suffer, whether we notice or not. And then a lot of this is going to be best practices. Now, obviously, we don't have time today to dive in depth into demos and examples and everything for each of these topics. That would take a week or more. But we'll talk about some of the top things we can do. If we're trying to solve problems, what are the best things we can do right off the top to get going on them? and we'll wrap up. We'll have Q&A, and then enjoy the rest of our days. So this is what I like to call the Triad of Forgotten. They're given different names before, some a little more colorful that may involve some more expletives. But basically, we're talking about performance, HADR, high availability disaster recovery, and security. These three fundamentals are pretty much what allows software to run. If we don't have this, then software can't form, can't run, we can't use applications. We simply can't. Things will go wrong and break, guaranteed. Sooner or later, they will break. And one thing they all have in common, which is a challenge for us, is cost. Everything here costs money, right? You want things to perform better? Need more hardware or better, more time spent on fixing things. You want better security, you got to put time and effort into it. HADR, you got to spend time and effort on it. So everything costs money. And so from a high level, most organizations view focuses on these things as cost. It costs money, it costs time, and therefore, should we do it or not? And it's a hard question to ask. The answer should be yes, but very often, because of this slide right here, these things don't happen because cost, right? And so we miss things. We miss a lot of critical pieces of application development that we should care about. And very often, we're busy. We don't have time, money, resources. At least we don't think we have them right now, right? You can buy insurance on an office or a home, or you don't have to. And if you don't, maybe something goes wrong. A lot of the things get missed in life when we're small. When you're a startup, when you're a small organization, you're focused on simply getting a product going, on surviving, and you may not think that these things are important yet, or they don't matter yet. Sometimes we just tell ourselves, this won't happen. These things can't happen to us. We're good, right? We write good code. And very often it's just easier to not worry about them. And not all this code is ours either. I'm including vendor software in every conversation we have here. And we all use vendor software for something, whether it be tools that we use for writing code, managing code, monitoring data, or platforms, or vendor software that we buy from somebody else. We rely on so many companies for tools. Some are big like Microsoft or Amazon or Google. Others are smaller. We all have tools for monitoring, for maintenance, for who knows what. A very most common reason I think that fundamentals get missed is we prioritize new features over fundamentals. Simply, we want to build new features into apps. That's more important than anything else. And we want to do it fast. Who doesn't want to do things fast? And so because of that, things get missed. They get forgotten. And these are all, the thing they all have in common is they're all business decisions. Everything here is a business decision. Not technical, it's business. If people want to do this, they will. If they don't, we won't. And we can't change minds without a little bit of ammo. So that's what we're going to talk about here. How do we fix these problems? And to really fix these problems requires reframing everything. Performance, HADR, and security aren't a cost, they're a savings. And that if things perform better, they require less compute. They're cheaper to host. If the security encounters a breach, that's a big loss. It could be downtime, it could be lost data, it could be embarrassment, it could be lost business. And at this highest level of availability, downtime is immediate lost time, money, and resources. So all of these things, when they aren't focused on, can cost us money, but by working on them, we can save money. And so for the remainder of this presentation, I want to think of all of this as savings. We are here to be stewards of savings, to improve things, not just the things themselves, but all the resources they cost. Because that's really the language that most businesses talk in, is savings, resources, time, money, effort. Those are things that matter a lot. And this is getting harder because data is evolving rapidly. If I were to think about the state of data every year or two, it's changing rapidly. Data is getting bigger. Every moment that passes, it's getting even bigger. Not only is it getting bigger vertically, like we have more files, more terabytes, more gigabytes, more whatevers, but it's getting distributed further. It's spreading out more. We have more servers, more locations, more data stores, more platforms that our data is stored in. And that can't be helped, especially if we're a large organization, it can't be helped. We rely on more tools than ever to get our jobs done, whether they are primary development tools, monitoring tools, alerting tools, plugins, whatever. We rely on a lot of tools. And because we use more than one data platform, we may not be the expert in all of them. The days where you simply have all of your data in a single database type, They still happens, but it's becoming rarer and rarer. More organizations will have multiple platforms for analytics, transactional, so on. And of course, as apps get more complicated and businesses get more complicated, so does the data. And we want to move as fast as ever, right? We want to develop software, develop features, and ship them as quickly as possible. Because in that regard, faster is better. Are there downsides to fast? Of course. There's always downsides to everything. But faster is better when it comes to delivering features to people that are hungry for them. And so the rest of this presentation is really about where do we start, the best practices. This is not a deep dive into like tweaking a query to make it faster. This is if you have nowhere to begin, where do you begin? Or if you're starting out, where do you start out? If you need to fix these problems, where are the best places to begin? And that's where we're going to start here is with best practices, the things that we do most of the time until proven otherwise, because they make our lives better. So we're going to start off by talking about performance. This is the one that I've personally had a lot of stake in over the years because, like everyone else, no one likes things that are slow. And the challenge we run into as developers is that everything starts off easy. We develop software and it always begins easy. We're in an environment that's controlled, the data is small, things are great, and even when we ship it to production, the data is still small, things are great. And then what happens is data gets bigger. And so our code may not have been great, but things were small, and then it gets bigger and bigger and bigger and bigger, and we can measure the size of data however we want, rows, gigabytes, terabytes, files, numbers of servers, tables, whatever. It doesn't really matter, but eventually things get bigger and slower, and then we're unhappy. People are complaining, and that's when it begins to matter. This is kind of the first challenge, and this challenge is completely countered by this challenge, which is that developing code for new features is not the same as writing code that performs well. I can write code that solves a problem in a million different ways, of which about 999,000 will be very slow, not perform ideally. But if it performs well enough and it works, no one notices. And so the second challenge is that innately our goal of writing new features will automatically counter performance because we're not writing code specifically to perform well up front. The number one way we solve this problem, especially when we're small, is just to throw hardware at a problem. Whether it's on-prem hardware or even easier cloud hardware, right? I just go in there and I click a few buttons and hey, I got some more CPU, I got some more money. And that's easy. It's very easy, which is why we often do it. But it does cost money and it doesn't really solve the problem. If there's a performance problem, it may be because we're bound by resources. And if we are, that's fine. But many performance problems are not caused because we have not enough CPUs or memory. It's usually caused by something else. And that something else requires research. Is it weights? Is it locking? Is it blocking? Is it a poorly written query? Is it a missing index? Is it a something? And so throwing hardware at the problem is a solution, but very often only puts off a problem until later when it gets bigger and bigger and bigger again. And at some point, we're not going to want to keep doing this forever. What I love to do, and I've been talking about this more and more and more and more because it helps give us leverage. As technical people, we want leverage to solve problems. We want to convince people that the right thing to do is spend time and make things perform better from a technical standpoint. And it's very hard to sell. And in an idealistic world, it would just work. But what really happens is you tell somebody, hey, we do this, and it gets faster and better, and everyone's happier. And they say, we don't have time for that. We don't have money for that. And so what I recommend doing, if you have any challenges ever selling people, is use FinOps. Go ahead and quantify the cost of a performance problem, whatever that performance problem is. It can be simple, like fixing some index problems, solving a complex query, whatever, making the right architecture solutions up front that may take time and effort. This is a direct way to counter cost, and it makes us a savings center instead of a cost center. So basically, if something performs badly, what does it really cost us? And then how does that impact that monthly cloud bill or your overall compute bill? And that allows us to take these technical problems and turn it into instead of gigabytes or gigahertz or megs or whatever, we're talking about dollars. And businesses can always talk dollars, always. Here's an example, and I've done this in real life more times than I can count, and this is extremely effective, and I recommend this. Imagine you have a big Azure SQL managed instance, supports a giant enterprise SQL server. It's big. It costs $500,000 a year. I made up the numbers here, but they're easy to work with. Let's say that a new problem query comes in. It's really bad, and it consumes just 10% of the available CPU memory. Now, at first glance, you may say 10% isn't that much, but if your server costs $500,000 a year, 10% is $50,000. Let's say you do a little bit of research and discover, hey, if we put in 10 hours of developer work, we can optimize this query and reduce that consumption by 90%. What does that mean? That means a lot. That means it'll save you $45,000 a year, which for 10 hours of work is $4,500 per hour. That's the value of that work. If you were to show these numbers to most managers or executives and say, hey, we can realize the savings, they will usually say yes. It's unlikely they will say no to money like this because this also gets bigger over time. We know from our experience as data gets bigger, these numbers will get bigger. So this is how we kind of put it into practice. We assign dollar amounts to things that are problematic to ensure that businesses understand the problem. They don't always understand technical problems, but they'll really understand this. And so this is a great way to get attention and begin to solve a problem. And once that's done, we can begin talking about making good decisions, because those good decisions can have dollar amounts and technical resources assigned to them. The number one decision I see that is made incorrectly is, where does our data go? This is the first decision that we make in data, and if you mess this one up, it's going to cost. It's going to cost a lot. Choosing the correct data platform is critical to everything going forward. Is it analytic data, OLAP, or is it transactional data, OLTP? That makes a huge difference. Store transactional data in transactional databases. Store analytic data or blob data or that file data in places that are optimized for that. Don't put it all in one place. We have bias as developers. We tend to think things we know best are the best solutions. But the reality is we don't want to do that. We want to put solutions in the best place possible. Identify, is this a highly transactional workload for order processing or a bank or for money or for things like that? Or is it eventually consistent? I'm posting cat photos in social media, and all I really care about is if it gets there soon. It doesn't really matter if it's there right now and right on time. Is it big data or small data? We'll treat them differently. A gigabyte of data is far different than a terabyte or a petabyte. So those things matter. We got to host it ourselves on premises. Are we going to host it as a platform, like a managed instance? Or are we just going to host it in software as a service, an Azure SQL database? And Amazon, Google, they all have their own versions of this, and you can use them there as well. Decide what type of data you're storing too. Are we talking about key value pairs? Are we talking about image data, text data? Because text is very different from numbers. You don't want to be sitting around in a transactional database, running queries against text. It's not ideal. You can, but it's not really what it's built for. Semantic search, Elasticsearch, those are very different than, running queries to insert, update, and delete rows. And will your data include PII, personally identifiable information, credit card numbers, birthdays, addresses, things like that, sensitive data that will require encryption or other considerations? These questions don't take long to answer. Most people could probably answer them in a day or less once you know what an app is. But taking the time to answer these questions will ensure that every decision going forward gets made correctly. If you don't make these decisions up front correctly, you're creating tech debt from day one, technical debt from day one that will come back and haunt you and make your life difficult, or someone else's life difficult, which we don't really want. Data types are kind of the next logical step. We have data, we know where to put it, we know what kind of data it is, and we know how we're going to use it. We know how the app is going to use it. We have to acknowledge the fact that all data has a type. It has types, it has names, we call it things, and it's important. Even in loosely structured data, it's still going to have some sort of type associated with it in the end. It could be very much loose, but it has to be something. We have to know what it is. If we don't know what it is, no one knows what it is. But fundamentally, if you compare data of different types, it's going to cost more. It's that simple. If you say I have integers here and I have strings here and you try to compare them, it's going to be expensive because I've got to convert one or the other or both to get what I want. So understand what data type makes sense when it matters. That way we avoid these problems. This will be a performance problem later on. right? It's going to be a performance problem if I try to get implicit conversions. And if you're not sure what the data type or the name or the structure for data should be, use standards. There's lots of standards out there already. If you're not sure how to store an address or a gender or a phone number or a postal code, there is so many guides out there already written by, ANSI and standards that have thought this through a lot more than you and I can, and we don't have the time to. So use a standard. Start with a standard if you're not sure, and you can adjust it later. And then as you choose your data types, just choose carefully. You have bits and dates and times and things like that. Just make sure they actually represent the thing that you want it to be. I am sure that we've all seen dates stored in strings, time stored as date times, money stored as integer pieces and things like that. We do lots of funny things in data because they're convenient, or they seem easy, or they're comfortable because we've done it that way before. But ideally, you should store things in a natural data type. A bit should tell you something useful. A date should be a date, a time should be a time. If it's a date time, I expect both a date and a time component. Nothing will irk me more than if I see 1/1/1900 at midnight. Well, does that mean that it's 1/1/1900, or does it mean that I'm talking about something at midnight? I can guess. I don't want to guess, though. Guessing is bad. We'll make mistakes. And certainly, if you hook up AI applications to your data later on the line and say, analyze my data for me, get insight for me. If your data types, if your column names, if your details are not ideal, it's not going to know any better than you do. It's going to make mistakes. If you need a secret decoder ring, I promise you everyone else will, and so will any apps that consume your data. We don't want that. Ideally, you need to know, will your data structures be understandable? And obviously, not self-documenting. Self-documenting isn't fully a thing, but if I look at your tables, your columns, your structures, I should have a reasonable idea what they do. I don't have to know exactly, but I should have a good idea without having to raise my hand and ask lots of questions. And here's a fun one. This is something that actually reaches out into a lot of areas of data. This really reaches into both performance and also HA and DR. That's retention. I have a whole presentation on retention, which people think is surprising, but it's not. This is one of the easiest ways to make things faster once you've had an app that's been around for a little while. If you could think of this up front, save more trouble. If you're collecting data over time, and there's a timestamp, date stamp, whatever, do you need it forever? And the answer often up front is, yeah, I want my data forever. But the reality is you may not need your data forever. You may like it being around forever, but if your users aren't going to use it after a certain number of weeks, months, years, if you don't even want it, if contractually you're obligated to get rid of it after a certain amount of time, do it. If you can clear out old data, not only does it get smaller, but it gets faster. Backups get smaller, all your HA sites, DR sites get smaller, everything gets easier and it gets faster. It really does. And it's not hard. I have fought this in different places I've been before, and once organizations are used to the idea of retention being something that saves money, time, and making everything better, they're happy with it. Once you have a data retention policy, that gives you direction. You can now have steps for compliance. You can keep things manageable. The table that has, I've seen people collecting data going back 5, 10, 20 years, and no one ever looks. And you don't have to just delete data. If you want to, data retention can involve things like compression, archiving, putting it in a separate table. And you can test this out yourself. Go into any place where you have stuff on the internet for a long time, like maybe you order stuff online. Looking at your recent orders in the past week is fast. If I try to go in and view an order from 10 years ago, I can promise you it'll be slower. They don't put that in the same place because most people aren't going to go to that very often. Most people are going to go for the last 5 or 10 orders or the ones in the past 3 months. But people very rarely go back 10 years. Same for your credit card statements or bank statements or anything else. People don't go back more than a certain amount of time very often, and if they do, they'll be okay waiting an extra second or two. So retention isn't just about deleting old data, it's how do I store it to get the most of my data and use it correctly. It's a good question to ask. And consider scalability too. When I scale data, do I scale it vertically, making it bigger, more rows, more gigs, more stuff, or horizontally, more databases, more servers, more places that I put things. Again, horizontal and vertical are both ways to scale, and for different applications, one work better than the other. Horizontal, you have the challenge of management, but everything's smaller. Vertical, you have a bigger thing that has to get dealt with, but it's all in one place. This is one I love too. I've seen this more times than I can count. Not every query performs badly. Not every performance problem is caused by the one big bad. Sometimes it's caused by things that happen over and over and over. And I look out for this because if you're searching for queries taking 5, 10, 30 seconds and you don't find any, you may think everything's great. But then you go searching and you profile, use query store, you check for things like that, you suddenly discover, whoa, there's a query that runs 30 million times a day doing the same thing over and over. Is that really necessary? And the answer is probably no. Maybe we can cache it or do something about it. But this happens all the time. This is not an isolated thing. I've seen it everywhere in my life. Keep an eye out for this too. Not everything is just one big bad thing. Sometimes it can be the same thing hitting you over and over and over millions of times. And complexity is a big part of it too. Those frequent queries that hit a million times a day could be simple, but we often are struck with big problems. I'm sure some of us here have seen stored procedures that are like 10,000 lines long, queries that have 100 joins in them, things like that. It sounds crazy to some people, but those things happen. They're out there, and they're going to perform poorly because they're complicated. The query optimizer in any engine, like SQL Server, will have to evaluate combinations of joins, tables, operators, how to get our data. And the more complicated your query is, the harder it is to get a good plan. The more complicated your query is, the more things that have to get done. Simply more stuff that you have, tables, views, functions, whatever, the more complex everything is, the more chances there are not to get a bad plan that performs poorly, but to get any decent plan possible at all. If I want to get data from 100 tables at one time, it's going to be really hard. And so the best advice I can always give is when you have a big problem, split it into smaller problems. Don't be afraid to take the big, horrible stored proc and break it into 4 smaller ones. Don't be afraid to take a giant query and split it into a few smaller ones. There's no downside to this. It only helps. And each one of those things is a smaller, easier to manage unit that can be tested and worked with and used. So big problems, break it into smaller problems. It'll make your life easier. It'll make things more maintainable as well, and they'll perform better, which ideally is what we want here. One final note on performance, and this happens a lot. I see all the time, everywhere I go, hacks and speedy fixes, things people did to get out of trouble as fast as they could. Either they had a problem in a production environment, found a fix, put it in place, were happy, and then were done. Or they took that fix and began putting it everywhere because, hey, if it worked there, it works everywhere, right? But keep an eye out for these because quick fixes will come back and bite us later. Things like query hints, forcing plans, trace flags, random use of local variables and dynamic SQL, tons of indexes all over the place, just spamming more indexes in a table than you should. Weird tweaks too. I see people argue at length online about should I use in or exists? Should I use not in or not exists? Should I do a left join or an inner join? I'm not sure. And they'll debate it for performance reasons. But the reality is you should write code to solve your problem and avoid weird tweaks if possible. If a tweak helps, that's great. But if you find your performance is just a hairpin between in and exists, I would wonder what else is going on. Are you missing an index? Is something else going on? Is the query very complicated? Why is it so sensitive to a small change? And sometimes it could be the optimizer, but usually it won't be. Usually there's a better reason for it, and it's worth looking into it. So, in general, avoiding hacks is good. The only real time we can do these and feel good about it is in an emergency. It's 2 in the morning, something's broken, we're not sure why it's broken, we can fix it right now, force the plan, fix it, done. But then you have homework. The homework is go back later and find out what was really wrong, resolve that, and get rid of the hack. That's important. Otherwise, each hack becomes a piece of tech debt you're stuck with forever. That's not ideal. So that's performance. And a lot I said, a lot I didn't say, but the fundamentals there are key. Getting things right the first time is very important towards getting things right in the future. And that leads directly into the next kind of challenge we have, which is availability. Availability is 100% a business problem to solve. It can be technical and we have to do things, but a lot of it is business. And the reason is because we need to define, before we can even talk about HA or DR, we've got to define critical components of how we're going to do it. And those things are RPO, RTO, and availability. If you don't define these, you can't really have high availability or disaster recovery that's reliable or that does what you want it to do because you don't even know what it wants you to do. Every organization should answer this question. It may be an easy answer. It may be a hard answer. The bigger you are, the harder it'll be probably, more complex it'll be. But it's a really good question to ask because without this, we're hopeless here. RPO stands for Recovery Point Objective. This is, in the event of a disaster, how much data is it okay to lose? And of course, everyone will start off by saying none. Don't lose data. But then you show them the cost of what does it cost to have a system that never loses data, and the answer is a big number. So then we kind of get into a conversation, and more often than not, organizations will settle on something like 15 minutes or an hour or 10 minutes or something like that. We back up our databases with transaction log backups every 15 minutes. Therefore, worst case scenario, a disaster happens towards the end of that cycle, we lose 15 minutes of data. And that sounds terrible, but yeah, this is for a disaster. This doesn't happen every day, I hope. And so it doesn't happen often. You've got to pick a number here, though, and that number has to correlate to your systems that manage your backups and recovery processes. You don't have a choice here. It'll correlate a lot to your backups and your data copies wherever they live, whether they're in Azure, whether they're in AWS, whether they're on premises, whether they're in a vault somewhere over there. Where does your data reside? Where do secondary copies of your data reside? Do you only have one copy of your backups? Do you only have one copy of your production data? And is that okay? Or is that risky? Simply cold copies of data for the sake of DR are not expensive. So consider that as a easy solution to the challenge of what happens if my backups vanish, for example, or something like that. And how current is your backup data? That'll define RPO. If you can't get your data from here to there on time, your recovery point objective is whatever data would be lost if it breaks right now. That's basically what it is. Recovery time objective is measured very similarly. It's if there's a disaster, how long will it take for things to come back up? And again, everyone loves zero, but the closer you get to zero, the more exponentially expensive it gets. Really expensive. And so what ends up happening is you come to a compromise where you say that if things go down completely, we can have it back up within however much time it takes to bring up new hardware or use our existing hardware or get those backups up and running, whatever your solution is. This relates completely to how available is your secondary data and how fast can we get it. It's bound by process, but it's also bound by resources. How much bandwidth do you have? How fast is your storage? Because ultimately, you're going to have to read all that data and get it back into a place where I can use it. Regardless of what it is, is it a secondary site where I just need to turn it on and flip a switch? Is it restoring backups for 100 databases or one database? But what will it take to resolve it? How long will it take? How hard will it be? And the last one, which is kind of fun, is availability. This defines uptime for data access. Most applications are not true 24/7 apps that have to be up all the time. Most are not. They can have varied usage based on location, based on the app, based on the needs. Is it transactional? Is it analytic? Or the industry and sector. What does this industry tend to have the highest business by? And, can we get scheduled maintenances when we need them? And those things can really help us. We can then realize that, hey, we don't need our app up all the time. It can go down once in a while for planned maintenance or to take care of problems or resolve an ongoing situation in a structured manner as opposed to waiting for things to fail and break. And we can get creative here because of this. If you know that people don't have to be up all the time, we can get creative in how do we restore things? When do we restore things? How much time do we really have? Because we might have more. So it's something worth considering. Define availability for your app. When do people need access? When is access at its peak? When is it at trough? And some apps do have even access all day long, but most don't. Most have busier times, less busy times, or acceptable downtime, which is also kind of nice. These all come together. These are business decisions. A technical person should not decide what these are. It's a conversation that occurs between technical leaders and business leaders determine what can we promise our customers. Our customers, our users they have expectations. So this helps us manage those expectations. And so this decision has to get made by everybody involved. You can't decide what the hardware is going to be or the solution is going to be until we have these defined. So they all need to be measurable, and we need to understand them and agree on them. And uptime is your ultimate metric here. What's the uptime going to be for each thing that we have, and how does that measure here? Because the moment it's a disaster, the clock is ticking. You have a certain amount of time to resolve the problem. How do we do it? What's involved? And that's the key. So these definitions are really, really important. And without them, we're destined to fail. The key about all this, of course, in data is data size. The larger your data is, the bigger your data is, the longer it takes to restore it, the harder it is to ensure that we get more data back in the event of an emergency, the longer it takes to back it up, copy it, restore it, and the longer it takes to recover from an emergency. All these things take longer the larger your data is. That's just natural. And so if you can reduce data size at all, or if you can scale horizontally, that will make your life easier. You can have better RTO, better RPO. Retention can help. Compression can really help. If you've ever used compression on data before, a lot of platforms automatically compress their data, but it's worth looking into. How can we compress data to make it smaller? This is especially good on log data, historical data, analytic data. That kind of stuff is very favorable for compression. It'll even perform better on top of simply, being smaller and backing up faster and things. If you don't have compressed backups, compress the data first, vice versa. The things to think about here that your data size will factor directly into how long and how much data is going to get lost in the event of an emergency. Lots of solutions out there. You probably already have some. At its most basic, there's hardware redundancies. We have, multiple of network switches and storage drives and database servers and storage locations for database files, and backups are copied from point A to point B. We have clustering to manage that, failover clusters. We have availability replicas, always on, log shipping. There's so many things here that we do that bridge the gap for high availability, and they can be used for DR as well. Some solutions can be used for one or the other, or even a little bit of both. You just define that. Like, what is the purpose of a solution? Is it high availability? Is it disaster recovery? And how effective is it? How effective will it be if things go down, if things break? And how much can you afford? And there are third-party solutions out there, third-party hardware and software solutions that will do all this for you if you want, and you may already have some of those. But if you're going to use them, you got to understand them. How do they work? Where do they go? What do they rely on? Because you can't just plug it in, play it, and forget about it. How does it work? And again, a lot of availability is bound by I/O. How fast can I get data that's changed here to here? Because all that really matters is change data. If I have a terabyte of data over here sitting and only a gig changes every hour, I need the ability to be able to write a gig of data from here to here as quickly as it comes in. If I have latency, if my always-on replica can't keep up, if I run a giant software release and now everything's falling behind, that's a problem. And so you just make sure that no matter what happens, you have more than enough bandwidth, more than enough specs on your hardware to handle whatever you're writing, the amount of data you're writing, how fast you're writing it. That's critical. DR is the flip side, and it will sound a little similar, but it is different. DR really focuses on getting back your data. So if something's happened and the data is not there anywhere, you have to get it back from somewhere. That's somewhere, depending on your cost availability, is going to be maybe a secondary site. You have a replica, you have backups, you have snapshots. Server snaps are convenient. They're not the same as database backups, though, but they're very convenient for simply bringing something up. And you can use these solutions, too, for dev and QA. A lot of the things that we use for HA and DR can be also used for, we need databases to test on, we need servers to test on. This is also a great way to do that, too. A key to DR, though, is that it has to be separate from your primary data source completely. If you store them in the same drive, the same server, that's still a single point of failure. And so it's really important that whatever you have for DR is stored in a totally separate place, that if this goes down, that is very unlikely to go down. If both can go down at the same time and become unavailable, then you're sunk. You have nothing. So it's important that they're separate as possible. I mentioned single points of failure. they're actually hard to avoid. At the end of the day, we often will settle on them for providers, for login providers, for platforms, but we want to try to mitigate them where we can, especially the ones that are in our control. For things like hardware, it's very easy to have duplicate hardware. For data, it's really easy to copy it. We take backups and put them here. Can we just copy them over there? Done. If we have a server, it's up here, can we copy it over there and have it ready to go somehow? It could be a snapshot, it could be backups, it could be always on, but do you have a plan available? That's important. And if you have data with no backups, that's a single point of failure. No copies, single point of failure. And document this too. If we know we have problems, and some organizations know they do, at least know what they are so you can deal with them if they happen. Have a plan. Otherwise, these will eventually become a disaster. Just time is all it takes. So to get us there, you develop what's called a business continuity plan. This is a business plan. It can be 5 pages, it can be 500 pages. Depends on the business, the organization. For some, it's just a few pages. But basically, this is a playbook for disasters. It's what do I do in the event of a disaster? If there's disruption of service, which is easy to happen, right? Yesterday, Verizon had an outage. Wireless customers all over the place were having trouble and couldn't access their cell coverage, and that affected a lot of processes out there. What do you do when things break? Have a response plan. It's not to be complicated, but really, who will respond? How will they respond? And you have priorities then when things go down. If you have lots of customers, lots of users, do they all get access equally? That might just be a little slower now that things are broken. Should we bring certain ones up first? If you plan an outage, will that result in a problem getting solved faster than if we try to muddle along with things half broken? And is it possible for some apps to have an outage and other ones remain up? Having a plan means that we can make good decisions even under stress, even when things aren't working well, which is hard. That's a really important thing. If it's 2 in the morning and something is broken, I don't want to start thinking up a plan right now. I can, but it would be great if I had something already written up on what's going to happen. And that also gives expectations to the business to know what's going to happen as well. So we don't have all the pressure on us to simply go as fast as possible. And last but not least, whatever you have for solutions, test them. This is really important. Having backups is great. If you don't test recovery, we have no idea that it works. Test recovery. Whatever scripts, whatever tasks, whatever jobs, whatever things that you have that are used for HANDR, that are used for recovery, test them. Treat them like software. They're apps, you test them, you maintain them, you QA them. And if there's emergency situations that could happen, try them out. Test them, give it a shot, see what happens. Simulate a disaster and figure out a way to ensure that the response by everybody is reasonable. Can we get things back up in time, or is that a pipe dream and we can't actually do it? Because I've been there before. I hope you haven't, but if you had, having executives standing behind you while you're trying to get a job done and fix something is really, really rough. No one feels good about it. No one likes it. That's what we're trying to avoid.
Just to
What's up?
remind everyone, the Q&A for question and discussion if you have. It's a bit quiet, so everything is clear, obviously, but feel free to use it.
Thank you. And if you do leave a question in the Q&A, I can see it out of the corner of my eye like this, and I can respond to it as well. The last of the 3 things here is one that's most publicly noticeable, and that's security. When things go wrong here, everyone knows, and we talk about this a lot. The first step towards having secure anything is inventorying it. What do we have? What data are we responsible for? Where is it stored? What is it stored on? What are the versions? What are the additions? Is it vendor software or is it our software? What do we have for logging, for performance, for metrics, monitoring, alerting, those kinds of things? If it's applicable, if we have our own hardware we're managing, what's the hardware and firmware look like? And if we don't, great. In terms of logins, users, permissions, roles, schemas, that kind of stuff, what do you have? This is really just an inventory. And there's people have written scripts, I've written scripts out there to do this for you, to do a lot of this work for you. You can't do everything, but it can do a lot for you. You ultimately have to know what you have. If you don't know what you have, you can't do anything. So this inventory is really important, and it'll help you in the future. If you ever actually have a SOC audit or a security audit, having scripts available already to get all this for you will just save you time later, and it's a good thing. The first fundamental principle that we care about in security is least privilege. This is the most fundamental best practice out there. And all it says is that simply any user, any login, any application should only have access to what is needed to do what it has to do. And this gets violated all the time. I see it everywhere all the time. But by simply doing this, it reduces your attack vector by a lot. Like the ability for somebody to get in somehow, exploit a user, and get at critical systems is reduced when that user can't do as much as they could. Because of that, all the system-generated stuff, admin logins, SA, root, whatever, just don't use them. Give them a crazy password, disable them, don't use them. Nobody should be logging in as SA. It's just ridiculous. And it's the most common thing people will try to log in and attack. If you have it available and it's enabled, I guarantee somebody's trying to get into it. So don't use it. If you have domain auth available, like Windows domain auth, integrated auth, use it. It's way more secure than having passwords floating around. Can't always do it, but if you can, it's far better than having passwords and files that get loaded and all that. Just don't have to worry about passwords as much anymore. So domain auth is really nice if you can use it. Highly recommended. It helps make principal least privilege easier. And kind of hand in hand with that is division of roles. Division of roles means that everybody gets their own login, their own user. That's all. Every app, every person, every department, every whatever gets their own thing. Shared logins are a huge problem. If you have 5 different applications using one login, it makes things hard to debug and understand what's going on. If something breaks, I don't really know who did it. But if you have one login per app, I can tell very quickly which app is broken or not working and where the bad query is coming from and whatever. And it makes life a little faster and easier. And so ultimately, there's a lot of ways to do it. You can use domain groups, schemas, roles, permissions, things. There's so many ways to do this. It's your choice, but the ultimate goal is the same, and that is to ensure that everybody has a separate login, separate users, separate permissions. That way you're not sharing things. Share just adds complexity. It's easy, just give out a login, say, hey, new person, use mine. But then when 20 things are using it, no one really knows anymore. And what happens when somebody leaves the organization? You have a coworker leave, and they know your password. Now you've got to change that password everywhere for everybody, which kind of stinks. But if it's just them and no one else, just disable them and move on. So it makes your life easier in the long run to have division of roles. It's worth mentioning here, sysadmin and DB owner. Don't use them. They're meant for true administrators, which there aren't a lot. No organization is going to have 20% of their developers be this. This is for people that truly go in and are responsible for administrative tasks, and it's not going to be a long list. Not apps, not vendors, not developers, not that power user, that one person who's been around forever that knows it all, not that product manager who's really knowledgeable, none of them. Some vendor apps will tell you they require this. You should push back and say no. Sometimes they're required for installation and they'll revoke it afterwards. That's okay, I guess. Not ideal, but better than nothing. But vendor apps are very guilty because it's lazy. It's easy to be able to say, oh, just give me sysadmin, I'll do everything and we're good. But that's not good because they have a security breach, their breach becomes your breach. And you can't do much about it. You're not the vendor. You can't write the updates for them. So make sure that you only use these accounts and these permissions when you need to, and never more, because otherwise you're just asking for trouble. And very few things need this. Very few apps ever actually, even if they're changing stuff, give them DDL admin, no big deal. Give them DB writer, give them whatever they need, but not everything. They don't have to break a server and bring it down. Should not be necessary. Not recommended at all. So let's keep on going. This leads to layered security, one of my favorite things to think about, in that just like how with availability and disaster recovery, single points of failure exist here too. If your security has only one line of defense, then we need to think about what can we do to avoid the single point of failure. If we have security in the database, but no other security that gets to there, that's a single point of failure. Ideally, your app should have security. Your database should have security. Every layer of access should have security. And each layer makes it harder for anyone to get in. So you want to have division of roles. You want principal of least privilege. You want to have strong passwords. You want to have so many things that all layer on top of each other for each level that we don't have single points of failure. Patching goes along with that. Without patching, we can't keep things up to date, and we're not responsible for that software. I'm not, I don't write the code for Windows or SQL Server. I don't write the code for Java or PowerShell. If updates become available, we have to update it because somebody else wrote the code. It's not mine. And there will be reasons to do this often. 0-day emergencies, do them as soon as you can. Automate this though. Ultimately, the best way to patch is to automate it because nobody is going to do this for you, and you're going to get tired of doing it manually. If you automate it, your life gets better. If you have legacy or unpatched software, that's a problem. Most organizations support some amount of it. Try not to support it. And if you're stuck with it, isolate it. Don't let everything else come in contact with it because if it's legacy, if it's unpatched, if it's a security vulnerability, everything that can get to it or it can get to is also a security vulnerability. But the ideal way to patch is to automate it. There's no simpler way. Just automate it. Don't look back. It'll be easier that way. Is it inconvenient? Yeah. But it's better than having to worry about it and lose sleep over it. So it's not the reason to have an outage, to have a security breach. It's just not. And one final note, I love this because this happens everywhere. Uh, Development environments tend to be the Wild West where everyone is a sysadmin, everyone's DB owner, everyone is everything because it's our environment. We're developers. We're playing. We're learning. We're working. But that's not good. Very often, development environments have proprietary schema. They have things that you want to get out. They probably have some customer data in there. They may not. I hope they don't. But odds are there's some, and therefore you do have to care about it. And so ideally, you want it to be as secure as production. You can have more people have access to it. There can be more details. That's fine. But simply having dev be a giant mess is dangerous because not only is it easy for people to get in and break it and then cause trouble, but they can use information from dev to get into production too. If they learn about your security, about your schema, about how your database is structured, the name of objects, they can just go right into your production environment and use that knowledge to try to hack you there. So there's a benefit in keeping development at least somewhat secure. Um, don't let it be the Wild West, though. That's just too dangerous. And it seems this way everywhere. But you should still follow best practices, even in dev, because we care. And we should care about this. It's important. And last but not least, just like testing your backups, testing HADR, testing everything else, test security. Do it yourself if you can. If you can't do it, find a third party. Find an auditor, a regulator, a security firm to do it for you. This is not hard. And they will find things, I promise. If you've never done this before, if you've never had a third-party security firm come in and help you out, they'll find things. They'll find things you didn't find, and it'll be good. You can give your employees incentives. You can do lots of other fun tricks to try to improve the chance you'll catch your own problems. But ultimately, catching everything yourself is hard. Having someone else come in and do it who's less familiar with your environment will help catch all the things that may not be as obvious, that may have not been caught. And things change too. Code that was secure 5 years ago may not be secure now. So you may have done everything perfectly correct then, and then vulnerabilities arose over time that changed things. So you can be 100% correct and still have a problem that comes up later that gets you. So consider this as a thing we should do as a matter of course, as a matter instead of we had a breach, let's react now. So I do want to wrap up here. I know I talked about a lot, but I do want to wrap up with time for questions at the end. The real key to this whole idea, this concept of forgotten things, of data fundamentals, is that these all relate. Performance, security, availability are all in the same basket. They relate. If one suffers, they all suffer, almost guaranteed. If you spend enough time making sure these are at least grounded in reality in your apps, then you'll have more success in the future. You can be proactive, and that's the key here. Work ahead to try to ensure that we ask the right questions up front. What should the data type for that be? To keep this data forever. What should the permissions really be on this object? Things like that. Those kinds of questions are the sort of things that will make our life easier later. And that's good. When we get reactive, that's where most of the emergencies come from. We're constantly panicking, we're reacting, where we're trying to fix mistakes with more mistakes. But if you're proactive and get ahead of these things and have plans and processes, take a lot of time, but this gets easier. It's no different than your health or your finances. Being proactive will help a lot more than being reactive. And if you need help getting change, use cost and savings as a hook. If you're trying to convince people this is the right thing to do, this will solve your problem. Assign dollar amounts. Use FinOps. Don't be afraid to say this is worth this. This will save this much if we do it. And that will help to build good habits over time. And once you have good habits, everyone's used to them. They become a matter of course. We don't have to worry about them. They become standards. They go from being something new to being something we always do. That's key. And then we know what we can do and can't do because of that. So I want to stop here, now that I've covered everything in the world, and ask, are there any questions about any of this? Because I said a lot, I showed a lot, talked about a lot, but what are your thoughts? What are your questions? What do you think in terms of data fundamentals?
Let me open the option to use microphone and camera as well. And if someone wants to speak, please use your virtual hand. There is an option on Teams above that says say raise. That means that you want to speak, and we will let you the option to speak. Let me change the setting in the meantime. And you can continue using the Q&A if you have anything that you want to write or say.
And Ronan, you double down there on temporary is the most permanent thing there is. Yeah, I've never seen a temporary fix for anything that was truly temporary. You think something's new and special, and it sticks around, and it causes trouble. It really does, and it always does. Are there any questions from anybody?
Okay, you can open your camera if you want to show yourself, say hello. Thanks a lot, everyone. And in the meantime, let's make it officially. I want to thank our speaker of today, Ed Pollack, for such a great review about performance, security, and resilience. And of course, thank you all for joining us today. I remind you to register to next week's meeting. You have the link in the chat, in the Q&A actually. And please help us to spread the word. This is a community meeting. We don't have any advertisement other than the community, of course. You can follow me on social media to get update information regarding the community and the recordings of the meetings. I'm looking forward to see you all next week, and feel free to use your microphone and camera before we are closing today's meeting. Again, thanks a lot, Ed.
Feel free to reach out as well. I'll grab that later. But connect online. You can ask questions later. I have other presentations. Some things that are very detailed with scripts and hands-on. Feel free to look me up.
Have a great day, everyone. We will close the meeting now. Bye-bye. Thanks, Ed. Thanks, everyone.
Thanks for having me. I appreciate it. It's been fun.